part of the brilliant team, not yet, wait, from my town in Lund, and that it's part of driving forward the innovation of district heating. So it's a great honor for me to introduce to you Dr. Kerstin Sernhed, Assistant Professor from Lund's Technical University. And what you probably don't know about Kerstin is that she has a golden voice and has been singing in choirs all her life. She has sung with Sven-Bertil Taube and soon with Sofia Källgren. Wow!
Okay.
All right, so I guess
Please.
we sit down now.
Thank you for that introduction, Moa. Now I will sing for you. I'm just kidding. I will spare you. It's nice to be here to see all of you. I come from Lund University, as Moa said. And I'm a researcher and a lecturer there, and I see some old students here. It's very nice to see you here working in this business. So I'm part of a research group. You have some faces here. We actually have Sara and Per-Olof here. Can you raise your hand? They're part of my group. And we have more PhD students. We had Lisa Brange. She was actually finished before summer, and she worked with bottlenecks and prosumers. I will show you some results from her. And then we have Sara, and she will actually talk about fault detection later on if you're interested in that. So we are part in the CoolDH project, and it's a demonstration project where you apply low temperature district heating in 2 areas, one in Lund in Sweden and one in Denmark. And we will hear about this later. So about Reto will tell you about Denmark, and Sara Mark from Kraftringen will tell you about Swedish side. So I won't dwell about this. Well, I want to start with the thing. High supply temperatures are costly. Sven was talking about this. But I want to show you a study which really showed this. And this was from Lisa Brange, and she worked with bottlenecks in the grid. And you know, a bottleneck is where you have a pipe with a too small diameter for the flow that is needed to supply the customers beyond the pipe. And she worked with different measures how you can deal with these bottlenecks. You can see increased supply temperature is one. That is one thing that we don't want to work so much with the low temperature district heating. Increased pipe area, of course. We have to have more flow to get the same amount of energy. More pumping. Local heat supply could be a solution for the bottleneck. And what Sven was talking about, we really, really need to work with the substations and with the customer installations in the houses. And also the pattern, the usage pattern, so we can work with demands and management. And these solutions, they really differ when it comes to costs from a life cycle perspective. And Lisa was doing her work in the Eon grid here in Malmö. And it was a real grid, but it was a fictive area she looked at. And she used NetSim for simulations, and she used interviewing staff about costs. So I will show you. She had more measures than I told you before, but I want you to look at this. It's a range because, I mean, it depends. It's always when you ask about cost, it depends about the grid, and it depends about the residues. But if you look at this arrow here, increased supply temperature, big network, it's actually going down to the floor, this arrow, in a big grid. It's actually going down to the floor, down to, I think it was 11,000 kilo euros could cost to raise the supply temperature. Now it was said that you should use this method for 1 month, just to be able to compare this. But still, you see, this is really, really costly. And it depends what we have for production and heat losses in the grid, of course. It depends, but it's really huge. And, I mean, for low temperature district heating, we can't use this raising the supply temperature so much, because maybe we will build with plastic pipes, and it can't take the heat, and we will use surplus heat at lower temperatures. So we don't have that means to work with the bottlenecks. So it means that we have to work with all the other ones much, much more. So, and I want to say something about the design criteria. Sven was into that. I mean, design criteria for district heating is we will provide the customers with heat. So it's the customers, their buildings, and it's their heating systems. And their usage patterns, of course. So in existing buildings, here we have the background is just the average return temperature and average supply temperature in Europe. You would say maybe it's a little bit high, but it doesn't matter. Well, to what do we use district heating? Now I'm talking about household customers in this case. Yeah. We want to shower, we want heat, and we want to be able to do the dishes. And there are different temperature requirements for this. We want to have, like in Sweden, we want to have 22 degrees. In UK, you have 17 degrees, so it differs actually. But the highest here is 45 degrees when we in the kitchen sink. So that is actually what the customer needs. But, of course, we have some problems with Legionella. And Legionella is a bacteria that can cause Legionella pneumonia, kind of lung disease by aerosols. And the hot water regulations says about 50. In Sweden it says 50. So, and as Sven said, in Sweden there are a lot of heating systems that are designed for 60 degrees. So in winter time we actually have to have higher supply temperature in order to suffice the customers. So this is for existing buildings, and it's exactly what you said, Sven. We could go down here if we don't have the faults. And we could save a lot if we do that. Well, for the new areas, I mean, we have the same customers. They have the same needs. Well, 45 degrees is sufficient. 50 degrees for the Legionella. But for the heating, space heating, we could suffice with 28 degrees for the customers. So here it's really the water, the domestic hot water, that sets the limit. And of course, I mean, you don't have to supply 55 degrees at the customers if the customers can heat it up themselves. You could use electricity for that. But then it's a question, do we want to have more installations? And do we want to have more electricity in the system? So, of course, the potential is bigger here. In CoolDH, we did a pre-study about domestic hot water regulations. And you can see it's 66 countries, and it differs, actually. You see that it differs on, they can have it on different places in the system, at the tap, in the tank, in the circulating water. And what you can see that Sweden has 50 degrees at the tap. Denmark has higher, but they can allow lower if it's peak hours. Norway is really high. So the design criteria will go up yet more in Norway. And Germany and France, they have something that is called the 3-liter rule if you have small systems. So when you have a heat exchanger and a pipe to the tap, and it's just 3 liters in volume, you don't have to apply to the 50-degree rule. It's like you have a villa. It's the same. But you see, it differs. And maybe we should do something about that. So actually, we will have different challenges for different situations. Do we have a new grid with new buildings, new low-energy buildings? Do we have a old buildings with a new grid, or do we have an old grid with old buildings? And this will affect who you want to influence. And I mean, I think this is the key. The key challenge here is not the technical things, it's how we work with people, how we work with the contractors, how we work with the customers, to be able to do this in the whole system. Otherwise, we can't reach this. In the low temperature district heating grid, we will have lower margins to work with. We can't raise the supply temperature, as I said. So we have really to work with all this. It will mean that we would have more customer interaction for fault detection, for demand-side management, for trying to get the customers to use the energy as efficiently as possible. It would mean that we have to make new business models, maybe new price models, maybe new services. Who should own the district heating substation? And can we actually make demands on the customers? Can we say that the customers should have this return temperature? Today we just let the customer do whatever it wants. Maybe we have a price model. And it actually means that we have to have a new type of organization in our district heating companies, be able to deal with these new services and new businesses. So, Søren was also saying something about standards. Well, I think you can hear Klaus. You hear? Lauritsen? Yeah, from Logstur. He has been working with plastic pipes for Cool the Edge. He can tell you about the challenges about standards later on. And we really need standards because we need the customers, the contractors to know what to expect. And maybe we need different standards. And maybe we need to know what are we talking about. Low temperature district heating. So the conclusion is lower operation marginals makes us have to work with customer side much more. And we have domestic hot water regulations that maybe need to be changed. Maybe we can solve Legionella with technical solutions, chlorinization, ionization, filters. Maybe. And we have to challenge the old ways. So it's actually the people, I think. We can do all the engineer solutions, but we have to get to the people. Yeah?
Thank you very much, Kerstin.
Oh, thank you.
So much to tell about this topic, and I think we have time for one question, and then probably you will have time to talk to people in the coffee breaks and during lunch.
Sure.
Well, great. Yes, we have a question there.
Hi, Helle from Holbæk Municipality. I just have a question about the Legionella, which you says is a problem, but I have just heard that in district heating, it shouldn't be a problem because you have flowing water, and so it's only a problem if you have it in still water for a long time, and if you have the continuous flow, then Legionella should not be a problem in low district heating.
Well, that is correct. If you have heat exchangers at every apartment, then you will have the same solution as in today's villas. So yes, but usually in Sweden and in Denmark and other places we don't have heat exchange at every apartment, and that's costly to install as well.
Okay, so there's a difference if it's a one house area or if it's a apartment building area. You can say you have
exactly. You have maybe a substation in the basement, and then if you have at all apartments, maybe if you have a supply temperature of 40 degrees, we don't know if that's sufficient still, but 50 degrees maybe yes.
Yeah. Thank you very much.
Thank
We'll
you.
leave the rest of the questions for later today. Thank you, Kerstin.
Thank you, Kerstin. Interesting presentation.